Hi folks, this is activity W8P1, which I didn't have a chance to complete in last week's class. So I want to show you how to do a cable join in Catia, and the first example that I'll do is two blocks like that, which is virtually connected by a cable. And then once I do that, I come back and do three blocks. Okay. Let's go ahead and do the first one on the left. So let me insert my first part, insert a new part in there. And I'm going to call this thing the ground properties, call it ground. And we're going to make it. So let me double click on it. On this vertical plane, I will sketch something that will be my ground, something like this. And although dimensions are not important, just for my own good, I'm going to put a dimension here so I have an idea of how big this thing is. Okay, it looks like it's 45, 46 millimeter. Okay, I'll make it 50. All right, so this is 50 millimeter, and based on that, we know what these things are. Exit. I'm going to pad it. Let me make it by 100 millimeters. All right, I should make it a little bit longer, maybe 200. All right, good. So now we go and insert our block. And since they're identical, they're going to be one of them. Maybe you copy and paste it, or do multi-instantiation, whatever you prefer. So insert a new part. Say no, this is going to be the block properties. So block and block. All right. Let's go make it. Double click on that. On that vertical plane, I will sketch. All right. Something small. Exit. And then we're going to pad it. Fine. That's good. And I'm going to change the color of that. Right click properties. I'm going to change the color to, I don't know, maybe orange, so I can see it better. Now, notice that this thing uh, is, I need another one that goes up and down this vertical edge. So let me copy this thing. And I'm going to go here, paste it. They're going to be sitting on top of each other. So let's go all the way to the top. Actually, I'm going to go to the assembly design. Okay, so move them apart. Uh, Manipulate, translate it in the direction Y so I can see it. There we are. I just noticed that, you know what, this is distracting me. So let me go ahead and make this path instead of 200. I'll make it maybe 50. I don't know why I made it so long. That's better. Okay, later on, I'm going to create another one of these and use it. But right now we have two blocks. Right now we're doing the one on the left. So uh, we're going to go to the assembly design, anchor the anchor ground, and then we want to have a prismatic between this and that edge, and this edge. So coincidence between this edge and that edge, and coincidence between this plane and that plane. That will turn into a prismatic one. Same thing over here, coincidence between this edge and that edge, and coincidence between this plane and that plane. Yeah. And then I'm going to move it down a little bit. I can use the compass or I can use the manipulate, whichever you prefer. There. Okay, very good. All right, so let's go to the digital markup, DMU kinematics, get the magic wand out, new mechanism, auto create, and needless to say, you're going to get two prismatic joints right there. Okay. We then go and click on the cable joint right there. See that cable? See this in the kinematic joint cable? It asks for two prismatic joint. Well, here's one. Here's the second one. And right now, let's leave everything the same. This tells you that which one you want to move. Is it prismatic 1 or prismatic 2? Let's say prismatic 1. And notice that there's a number 1 here. Let's see what that thing means. Say okay. And let me zoom in a little bit. So there's a sliding bar, and this can go between minus 100 and 100. Let me change the range here so that actually it doesn't go between 100. I'll go 0 to, let's say, about 50, something like that. I don't want to work with 100 and minus 100. Notice that now when you drag this thing, that top one moves between 0 and 50 millimeter. However, they're going in the wrong direction. That's the problem. So what I do is I go back to that cable joint, and instead of plus, I say make a minus 1. And let's try it now. Now they go in the same direction, you'll see. Okay. Except that if I want this thing to go in the other direction, there's several choices. One is, let me reset that. Let me see if I can flip the direction of the prismatic one. No, I can't do that because it's buried in a cable joint, no problem. So you go to the cable joint and you put a, flip on that arrow. Okay, very good. And then we say, okay, let's try it now. There, this is what I want. Okay, very good. Reset. Okay, so we have by the way, there was a number here. The one means that for every 1 millimeter motion of this, how much the other one moves. I don't want one, so let's make it 10. Let's see what happens. Try it now. Notice that for every 1 millimeter motion of the top one, this one moves 10 times. Now reset. I don't want 10. Let's go back. Make it maybe three times. So let's try it now. For every 1 millimeter motion of the top one, this vertical one goes by 3 millimeter. You can see that right there. All right. Reset. Good. Now we want to create our other problem. The other problem being this. Now notice that I need another block, and you can visualize that the cable goes between this and that. But the point is that the cable joint does not really have to be, has nothing to do with an actual cable. It has to do with the motion of two prismatic joints. So for example, I can take another block and place it on this edge so that as this block moves down, this third block moves horizontally in the x direction. It can be done. So don't be fooled that the other one has to be on this edge. In other words, the other block has to be as a continuation of that. That is not the case, but this is how I'm going to do that for the present problem. Okay. So let me go ahead. I need another one of these blocks. So copy, and I'm going to paste it, and they're going to be on top of each other. Okay. So let me move them apart and use the compass to do that. There we are. I'm going to move it down a little bit. There we are. And we are good. Okay. So what we're going to do is we're going to try to make a prismatic joint here. I can do that right now. Prismatic joint. See this? Between this and that, this plane and that plane. And then we say, okay, there we are. So a prismatic joint has been created. Okay. Now, you may be tempted to say, okay, let's go and create another cable joint. Now notice that I can select this, there's no problem, but I cannot select the other prismatic joint because those are all gobbled up by by cable 3. So what I can do is I can actually go ahead and create one, and which one would that be? It's going to be between uh, the one that I use, this edge and that edge, this plane and that plane. And the other one, I don't have to create because I already have one right there. This is the one right there. And then we say, okay, we'll come back to these length driven and stuff later on. Mechanism can be simulated, and let's see what happens. So we have a single sliding bar which controls the motion of that top block. Okay, that the first two are doing okay. The third one is not because of that ratio being the wrong direction. So we go back, we go to this cable, we make this thing minus, we say okay, and let's try it now. Right. And because that ratio is 1 or -1, every translation of this will produce the same translation of the other one. Now, if you don't want it, go change it. So, for example, I can go to that second cable joint. I'll make this thing 10. How about making it 10? Say, okay, let's try it now. Right. Every 1 millimeter of that, make this thing go by that ratio that I put in there. I can't remember what it was. And every motion of this is going to give you 10 times motion of that one. Now, keep in mind that this block, I could have put it on any direction in a sense that I could have created that prismatic joint on this, the slanted line, etc., and it makes no difference. So basically, a cable joint tells you that when one prismatic joint takes place, the other one should take place in any direction that we have, it doesn't matter, and by the ratio of the uh, value that you put in there. And worry about plus and minus if it's not moving in the right direction. Good. That's pretty much it. Good luck.